Good afternoon. Today, I'd like to talk to you about the fundamental driving force behind the information age, and that driving force is the search engine. Specifically, I'd like to talk about the role that the word has in how we search and how search engines are made. And finally, I hope that I'll be able to convince you that the word, in terms of search, is in desperate need of redefinition. But of course, before we can redefine something, we first need to define it. And my dictionary didn't fail to give me word, a single, distinct, meaningful element of speech or writing. And while this definition seems very natural to us, it's actually rather artificial if you consider the oral history of human communication. Regardless, we've come to this idea that the word is the atom of communication, a single, distinct, meaningful element that can be combined to form the works of Shakespeare or the English essay I have to write tonight. And of course, the other thing my English teacher always taught me is that word choice is key. And that's certainly true when you're trying to do a search on, say, Google. For example, in English, we have two different spellings of the word color, the British and the American. Being Canadian, we like to use both, sometimes even in the same sentence. But if you were to do a Google search for the British spelling of color, you'd find that the #1 Google search result would be a Wikipedia article about color. But if you do a search for the American spelling, the #1 search result is some trendy iPhone photo sharing app. And I don't know about you, but I find that a little bit disturbing, that you can search for the exact same idea with the exact same meaning with just a slight variation in spelling and get such drastically different search results. It's kind of strange, kind of funny. And I have to say that my own story also starts with Google. I was maybe 6 or 7 years old when I first used it, and being a 6-year-old, I thought Google was magical. But of course, over time, I've learned that Google is not powered by Phoenix Feather or Dragon Heartstring, and I've learned a little bit more about how search works. And I found that pretty much all of modern search theory is based on this thing called the independence assumption, which states that all words are completely independent of all other words. And then maybe 3 or 4 years ago, I was thinking some more about this, and I read an article about how this independence assumption is really breaking down. It's really breaking down because we're starting to search for shorter and shorter documents, things like Twitter tweets and Facebook status updates. And these documents are really hard to search because the pool of keywords is just that much smaller. And then I was reading this book that my parents lovingly bought me for Christmas, and there's a section on it. And there's a section in it where the author does a statistical analysis of the words found in British personal advertisements. And he found that the words that people used said something about them, and also about the other words that they used. And that made me realize that words don't exist in isolation. They carry with them this semantic baggage. And the example I'm going to use to illustrate that is Sendai, which according to the dictionary is a city in Japan on the northeastern coast of Honshu. However, as of, say, March 2011, Sendai carries with it this enormous semantic baggage that's associated with death and destruction, an earthquake and a tsunami. And the fascinating thing about that kind of relationship is that it's ever-changing and almost instinctual for a human to make, and yet incredibly difficult for a computer to understand. And so the fundamental problem in search then becomes, how do we help computers understand words the way we do? And the answer to that question is through relationships. And so what I did for my science fair project was created a new search algorithm, or search technique, that tries to find and understand and finally exploit relationships that exist between words. And so here I've put together a demo using some Twitter tweets about the Japanese earthquake and done a search for Sendai. And I showed this at the science fair. And you can see that the #1 search result that my system returns on the left is travel information, the earthquake in Japan. A highly relevant tweet that nonetheless would never appear in the traditional system on the right because it's missing that key word Sendai. You could say that keywords are key. And so what I found is that you can get better search results by understanding relationships. In fact, on some standardized tests, my system did twice as well as the existing system I compared it to. And so you might be wondering at this point, what is the Phoenix Feather behind this? What is the magic? And the answer is a mathematical model called a graph, which is basically just a big network of connections. And so here we have an example of a very simple graph showing how a traditional search engine would view the word Sendai, completely isolated and completely alone. But what my system tries to do is take words that appear in the same documents as Sendai unusually often and create links between them. And then it continues to do this until eventually what you have is a graph representing the statistical structure of the entire English language. And so you can take that then and a tweet like, say, travel information, the earthquake in Japan, and try and model it in this new model to try and get the computer to understand its meaning. So we could start by taking our model and saying that all the words that the author actually chose must be important to the document's meaning, because the author chose them. But then you also have words like Sendai that the author didn't choose and yet are really well clustered to everything that's in the document, and that's important. And so you can say that those words are important too. And if we continue to expand this model, we end up representing the meaning of each document to the computer in terms of a combination of all the words in the English language, rather than just the words that the author chose to use. Kind of cool. And I found that it can give you better search results. And then you might be wondering then, okay, what is the actual way that this actually works? What is the last piece? And it's randomness, actually. And it's called a random walk, which is exactly what I'm doing here now and exactly what it sounds like. You just start somewhere and move from point to point at random. And if I were to say give you an infinite amount of time, you'd find that you'd eventually visit every single node in this network, every single place. But more importantly, you'd find that you'd keep coming back to certain places again and again. And you can say that these places that you keep returning to are the most important nodes in the network, or the most important words in defining the meaning of the document. And so I think I've shown in my research that there are significant technological advantages to changing how we frame the word, how we think about the word. And so I therefore like to propose a redefinition. And that definition is word, a piece of meaning, and its semantic baggage. And I think that with models like these, we can accept that knowledge is power. And with models like these, we can improve search engines, which in turn can improve universal access to information and maybe make the world just a little bit better. Thank you.